what are we gonna do here, guys? We actually studied a few topics with you, and right now, really, I don't know your level, unfortunately. Okay, somehow we could not actually, how to say, set a good way of communication with each other, especially in terms of tests. Okay, and I wish if I give you a test in a certain time, you have to do them nicely, maybe on a screen, or just print out the paper and do it there and scan it well, send it to me back, and I can have a look and check how much you are learning, what is your level right now. But still, actually, that is unknown for me. It's a kind of riddle. I'm trying to solve this. So what can I do? Okay. But again, maybe after 1 or 2 weeks, after February 20, you're going to have another test. But this time, let's see. Okay. And you're saying that you are busy, you have school, blah, blah, a lot of things. I'm aware of everything. But, and also you are here to learn
Hello.
something. Okay. If I don't know your progress, actually, I mean, I cannot get what I expect, and also you cannot get what you expect. Okay, so guys, now I just want to give a break to our classes for a few, not for a few, let's say 2 weeks. Okay, so we need to focus on Sasmo. That's also practice, and after all, you're going to sit for this exam. Also, you need to be familiar with the exam. It's like that many international exams, like TOEFL or LTS or A level or AS level, GCSE, GCSE, O level, and SAT. I don't know. These questions usually a lot of students fail. Why? Because they are not much familiar with the technique, right? With the method. Okay, usually questions are not so hard, but maybe they have never practiced, or they are not familiar with the question, or maybe vocabulary. That's why they do not get high score. All right. Okay. And also Sasmo is something like that. Okay. What do they expect from students? And in Sasmo questions, they are usually uh, not so hard, but non-routine questions. Okay, just using a usual way, you cannot solve the questions, or the kind of tricky questions. If you just miss one point, you'll get wrong answer. In Sasmo, if you ever have seen the answer sheet, for example, right? For example, let's say just you need to write one answer. If your answer is a little bit wrong, that is completely wrong. Okay, so because only one, we have one choice: it's correct or wrong. And if it is wrong, even you get some negative point. Anyway, that's why how we are going to do this, guys. And here we are going to see the question, and I may give you some time. First you have to read and think. Okay, if you can solve within like 3 minutes, it will be great. If you have no idea, then we will discuss together, and after that I will just save it and share with you, and also at home if possible before you come to this class. If you have time, you need to have a look. And the curiosity, that's the most important thing. If you have curiosity, that is the most important thing. Otherwise, if you're not interested, and if people are pushing you to come to this class, um, you will learn. I don't say that you don't learn anything, you will learn, but not as much as we expect. Okay, good. Now, once again, we are going to solve problems S2 and S3 papers from 2013 to 2018. And right now I have those papers, 2019 and 20. I couldn't find yet. If we finish these questions, after that, I actually, uh, I'm going to get subscription for their website, and it's just $19. If you have, if you're interested, also actually can be a member and practice questions from there, right? edugain.com.sg. All right. So guys, now let's start. And these are just the rules and the time for this question: 25 questions, 1 hour, 30 and 30 minutes. It's 90 minutes. That means that actually, see here, we do not have much time. And every question, if you have 25, maximum 3.5 or 4 minutes, right? You need to solve the questions. And that's why if you don't practice well, the time will be the biggest challenge for you. Okay, so let's start with this question. Okay, guys, first have a look and read it, and this we can, maybe this first question we can try together, and after that you can try other questions yourself first. Then we will discuss. Okay, Hussein, can you read the question first? Hussein, are you there?
Yes.
Yes, can you read the question?
Okay. Tom must travel from A to B and he plans to go at a certain speed. He would like to arrive earlier than planned and notes that traveling at a speed 5 kilometers per hour. He would arrive 5 hours earlier and traveling at speed 10 kilometers faster than planned. He will arrive 5 hours earlier at his planned
Okay,
speed.
Hussein, is your interconnection bad?
Yes.
Because your voice is so. Okay. So if you remember, Mr. Arad, we did a lot of examples similar to this, okay? And what I taught during the class is all the materials are from Singapore, okay? And I collected these materials not in 1 or 2 years, maybe in 15 years, because I taught at international schools for about 11 years, and I was using Cambridge and Singaporean books, and somehow I don't know, questions material so beautiful and nice, it really improves students thinking skill, problem solving skill a lot. So here it says that the Tom must travel from A to B, so we are talking about speed and time problem. So let's say this is A and this is B, right? And he plans to go at a certain speed. What is the speed? I don't know. Let's say his planned speed is x kilometers per hour. He would like to arrive earlier than planned and notes that traveling at a speed of 5 kilometers faster than. So here, suppose that the distance is d, right, and time is t. Then the first case, if he travels at x kilometers per hour, let's say it takes t hours. And the second one, it says that he would like to arrive earlier than planned. Even in the, for example, suppose that you're in the exam, and of course we need to read fast and try to understand fast, because just knowing something, it's not enough. Speed is very, very important life, right? If I say, oh, Arat, there's a fire, and Arat hears me, and after one day he understands what I say to Arat. Okay, and after that he runs to the somewhere. Okay, it's too late, but immediately we have to understand and process and give a response, and because everything is limited, restricted, right, speed is very important. Anyway, he would like to arrive earlier than planned and notes that traveling at a speed 5 kilometers per hour faster, right, than planned, he will arrive 5 hours earlier. So here we are talking about D, right? If he increases his speed by how much? Plan and knows the travel speed 5 times faster. It is plus 5. And it says that he will arrive 5 hours earlier. So here we have T minus 5, 5 hours earlier, and traveling at a speed 10 kilometers faster than planned, he will arrive 8 hours earlier. So here, if he increases his speed by 10 kilometers, right, and he will arrive at his destination 8 hours earlier than planned. So that is t minus 8. What is his planned speed? So we need to find x. So how many equations here? We have uh, actually three equations, right? And we have two variables. And of course, we can solve this because number of variables is less than number of equations. Anyway, from the first one, if we just remove this, right, expand this, what we have here? Xt, right? And the minus 5x and the plus 5t and minus 25. The second one is here. Here we have xt, right? And the minus 8x and plus 10t minus 80, right? So we know that this xc, they are d, right? And this d, they cancel each other, this one. And also these things, they cancel each other. Now what do we have here? Here we have, actually they are equal to 0, right? Minus 5x plus 5t. Take 25 to the left-hand side. Here we have 25. The second one, minus 8x plus 10t is equal to 80. What is it? Just simultaneous linear equations. Now, if you just multiply the first equation by, let's say, -2 and add here, right? And multiplying by -2. Let me change marker. I don't like red. If you multiply by -2, -2 times -5 it is 10. 10 plus -8, that's equal to 2x. -2 times 5, -10 plus 10, that's equal to 0. -2 times 25 is 50. 50 plus 80, that's equal to 30. So what is x? X equals 15 kilometers per hour. Arat, any questions?
No.
Yeah, it is. It's not, as you see here, the idea, everything you know that, but the problem is, can you solve this fast? Can you solve this question in 2.5 minutes or 3 minutes? That's a problem. Now 48, I think. Now 47. Question one, it is 15, so it is correct. Also, we have answers at the back. Okay, guys, let's continue. Now I will ask you the next question. It's an interesting question, and let's discuss together, and you will see.
We saw the answer.
Huh?
But we saw the answer.
Yeah, we saw the answer. I can show you the answer, but can you get the answer by solving this? Okay, it's not about if you don't know the answers, then how do you know that we solve correct or not? And that's why first we have to solve this. And can you get that answer? Okay, I mean you're thinking, and based on some principles, does it lead you to the right answer or not? If it is, if it takes you to the right answer, that means that we are thinking in the right way or solving in the right way. Okay. And that's how we learn math. Otherwise, if you don't know the answer, how do you know it's correct or not? Especially when you're doing self-studying. And that's why every book must provide, it's a must, it must provide answers to the students so that you solve it, check your answer. If it is correct, move to the next question. If it is not correct, then search your mistake. Where did you make a mistake, right? And in this way, we learn something, okay? Anyway, on the island of nobles and liars, 50 people are standing in a queue. All right. Everybody except the first person in the queue said that the person before him in the queue is a liar. The first man in the queue said that all people standing after him are liars. How many liars are in the queue? Nobles always speak the truth, and liars always tell lies. Okay. Now it says in this kind of questions, all right, to solve this kind of questions, what I think, maybe you may think differently. In math, we have one term, we call this analogy, right? Analogy. Analogy means similarity, a similar thing, right? So first, we have to just think of the simpler version of this problem, okay? Instead of not 50 people, how about if we have 4 people? How would you answer this? If you have 4 people, let's say here in the first, we are talking about here A, right? In the first place, and behind A, we have B, and behind B, we have C, and behind C, we have D, right? Okay, now it's a 54. Everyone except the first person in the queue said that the person before him in the queue is a liar. So this says that, right? This B says that he is a liar. And C says that it is a liar. And D says that it is a liar. And the first man in the queue, who's the first man? A, right? Said that all people standing after him are liars. How many liars are there in the queue? So that means that here, this what is it? B, right, is saying that it's a liar, and also it's liar, and also it's liar. So this means that this A, everybody is liar, right? So the first man, the Q said that all the people standing after him are liars.
So
How
B
many
is
liars? Huh?
so B is saying the truth. C is again lying. D is saying the truth.
Yes. So at that time, as you see here, because one is how to say uh, denying, right? Their claim here. So that means that one is liar, one is noble. One is liar, one is noble here. So here, since we are talking about 50 people, with the question, how many liars are there in the queue? So there are 25 liars in the queue. That's a kind of logical question. And I don't know, sometimes it may take time to think and understand this. If you practice this, if you know that, you can do fast. Otherwise, if you see this kind of question for the first time, okay, let's move to the next question. Narmin, can you read this problem for us? Are you there?
Yeah, I'm here. In a football league with six teams, A, B, C, D, E, F, each team plays each other team exactly once. So far, A has played one match, B has played two matches, C has played three matches, D has played four matches, and E has played five matches. How many matches has F played so far?
Okay. Now, Narmin, if I ask you, how would you solve this problem? How would you solve this problem?
Um,
I mean, what method will you use here? For example, you understand the question, right? In football league, every team must play against the other teams, right? Like A, for example, A should play against B, C, D, E, F. And after the B, against A and C, D, E, F, right? So it's said in a football league with six teams, each team plays each other team exactly once. So far, A has played one match. Maybe played against B or C or D or E or F. We don't know, but against one of this. And B has played two matches. C has played three. D has played four, and E has played five. How many matches has F played so far? What I think is these kind of questions. Actually, I usually draw a circle and denote this, and you can see this, or a kind of even, I don't know. Let's say here we have A, and here we have B, and here we have C, and here we have D, and here we have E, and here we have F, right? So it says that F and what is it? D has played four matches. So here, four matches, maybe again E, right? Okay, where is it? D has played and E has played five matches. Here we have E, remaining numbers 1, 2, 3, 4, 5. That means that E has already played against each other. Now, if I just connect this, E played against F, E played against A, E played against B, right? E played against C, E played against D. It is gone. Five matches. Okay, so it is done. And D has played four. What is D? Here, right? And the D, and it cannot play against A. Why? Because A has played only one match, right? A played his match with A. So it is four match. So it must have played against B and against C and against F, right? So how many? It is four. One, two, three. Is it four? One, two, three, four, right? Okay. And also D is gone. And how about C? C has three against E, against D, one more thing, right? And how about B? B, two, okay, also finished, right? Okay, so C has played three matches, one against D, one against E, also one against F, right? Because he cannot play against B because P played only two, A played only one. So the question is, how many matches has F played? F played number one, number two, number
three.
three. So the dot, 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 F played three matches. Javed, do you understand?
Yes.
Okay, guys, if you understand, I want to ask the next question for you, okay? And I will give you maybe 3 minutes. It's about, I think, geometry, okay? Read it, do it, and tell me and the answer, and after that, explain how you got it, okay? So 3 minutes.
Teacher, can you explain the question?
Question?
Yes.
Question says that how many integers, we know integers, right? It is, okay, greater than three, that's three, four, five. Does there exist a convex n-gon whose angles are in the ratio 1 to 2 to 3 to 4 to 2 n? Okay. So we are talking about polygon, right? And its interior angles ratio. Like for example, if you're talking about triangle, okay? So that means that if this angle is alpha, this angle should be 2 alpha. This angle should be 3 alpha. If you're talking about some kind of quadrilateral, let's say, okay, if this one is alpha, let's say this should be 2 alpha, and this one is 3 alpha, and this one is 4 alpha, right? If it is n size, then it is the ratios of these angles are alpha to 2 alpha to 3 alpha to 4 alpha to 5 alpha to n alpha, okay, the ratio. So that means that such polygons which satisfy this condition, how many such polygons exist? How many polygons are there whose interior angles satisfy this condition? This condition means the ratio of their interior angles is 1 to 2 to 3 to 4 to n.
Thank you. But it's possible for every angle, every side.
No, how is it possible?
I say possible for everything.
Possible for every what?
Every integer more than three or three.
So you are saying that you can find, for example, let's say hexagon, whose angles, interior angles are can be in the ratio 1 to 2 to 3 to 4 to 5 to 6.
Yes.
No, I can show you that that's not possible for a hexagon, for example. Let's say if you're talking about some kind of hexagon, it's not drawn to scale, okay? Just suppose we have some kind of hexagon here, okay? And let's say this one is alpha, and this one is 2 alpha, and this one is 3 alpha, and this one is 4 alpha, this one is 5 alpha, and this one is 6 alpha, okay? And what is the sum of the interior angles of this polygon? Let's say it is S. That's equal to 6 minus 2 times 180 degrees, right? Which is equal to 720 degrees. Now, if you add this, what we have here? Here we have, again, the sum on the other hand. Here we have alpha plus 2 alpha plus dot dot plus 6 alpha, which is equal to alpha is a common factor. And here we have 1 plus 2 plus 3 plus 4 plus 5 plus 6. That's equal just the sum of the first 6 natural numbers. That's equal to 6 times 7 over 2, which is equal to 321 alpha, right? So now these things should be equal to each other, right? If you check this, 21 alpha is equal to 720. Now what is alpha? Alpha is 720 over 21, right? So what is it? What is it? It is, if you simplify by 3, for example, that is 24 over
34.28.
7. So that's equal to something. Anyway, that is
34 2 over 7.
um, anyway 200 over 7, right? Okay, that is 1
Teacher.
alpha. Now, if you substitute, for example, 6 alpha right there, the largest angle. What is the largest angle? 6 times alpha. What is 6 alpha? 6 times 240 over 7, right? So that is greater than, this one is greater than 180, right? Just one angle is greater than 180. But in the question, it says that convex. What does convex mean? Every interior angle is less than 180. Otherwise, it becomes concave, right? We have convex polygon. Convex polygon means every interior angle is less than 180. As you see here, this hexagon cannot be. Even if you just say heptagon, octagon, actually these polygons, they cannot satisfy this ratio. Anyway, actually that's the idea here. Just a minute. Okay. So that's the idea. Now, how do we do that? Since we are saying that suppose that n is greater than or equal to n, right? So here the sum of the angles that's equal to alpha plus 2 alpha plus dot dot plus n alpha, which is equal to, as you see here, alpha is a common factor. So the sum of the initial numbers is n times n plus 1 over 2 times alpha, right? So that is equal to n minus 2 times 180 degrees, number one. And number two, and also the largest angle is n times alpha. This n times alpha should be less than 180 degrees, right? Which means that alpha should be 180 over n. It should be less than this. Then it satisfies this angle. Now from here, what do you get here? If you solve this one, right, 180 over uh, that alpha, here we have alpha, okay, less than, alpha is equal to, right, 2, that is 360, times n minus 2 over n times n plus 1, right? So this should be less than 180 over n, right? That's alpha. I just found alpha from here. So that's alpha, right? It should be less than this. Now, if you just solve this and cancel each other. 360 also divided by 180. So what do we have here? Here we have 2. 2 times n minus 4 should be less than n plus 1. N plus 1. Or this n should be less than 5. Okay, even it cannot be equal to 5. That's why what numbers are greater than or equal to 3 and less than 5? So dot dot dot, only two possibilities, 3 and 4. And only in triangles and the quadrilaterals this case is possible, otherwise it's not possible. Okay, if our polygon has more than 4 sides, and the ratio of the interior angles will never be 1 to 2 to 3 to 4 to 5 to, I mean, this. Okay.
Teacher, but why did you write 360 times n minus 2? Why not 180?
What?
Teacher, at the part which is alpha is equal to, you wrote 360 times n minus 2. Shouldn't it be 180?
No, no, no. Here, Arad, uh, from this, if you find alpha, what is alpha? Multiply both sides by 2, right? And divide both sides by n times n plus 1. So 2 times 180, it is 360, right? And in the numerator, we have n minus 2. In the denominator, we have n times n plus 1. It's 2 times 180, it is 360.
Thank you.
Okay, good.
Okay.
All right. That's also another easy question, but let's do this together, okay? And after the next question, I will ask you. Okay. A sequence of numbers has 6 as its first term. Okay. And we are talking about a sequence of numbers. The first term is 6. And every term after the first is defined as follows. If a term A is even, the next term in the sequence is A over 2. If a term B is odd, the next term is 6B plus 1. Thus, the first 4 terms in the sequence are 6, 6 is even, so half of 6 is 3. Now 3 is odd, 3 times 3 is 9, 9 plus 1 is 10. 10 is even, right? If it is even, so again, if it is even, we are just using this A over 2. 10 over 2 is equal to 5. It is odd, 3 times 5 is 15, 15 plus 1 is 16, and half of 16, it is 8, and continues. If you just write a few of them, then you'll see the pattern here. 8, right? And 8, half of 8, it is 4. Half of 4 is 2. Half of 2 is 1. Now it is odd, and the 3 times 1, it is 3 plus 1, it is 4. It is 2 and 1. Now it's just repeating. You see the pattern here. What is the 200th term in the sequence? Now starting from here, right? It is 4 to 1, 4 to 1, 4 to 1. Before this, how many terms do we have here? Before this, here we have 6 terms, right? 6 terms. So that means a 200th term. So here we have 6 plus, how many streets do we have here before 200? So here we have 60 or 65, 65, 63, 64, 65, 65, 65, 195. Okay. If it is like this, for example, 65 times 3, not 65. Let's say 64 times 3, right? Which is equal to, here we have 64 such groups, right? Repeating 4 to 1, 4 to 1, 4
192.
to 1, 192, and plus 6,
56.
198, right? So this one is 4 to 1, and this will be 198th term. After that, it will be 4, 199, and it will be 2. So what is the 200th term of the sequence? 200th term of the sequence is 2. Okay? All right. Guys, next question is for you. Read it and do it. You have 3 minutes, and after that, we will discuss together. Okay, 3 minutes.
Teacher, I finished.
What is it?
5 over 36.
5 over 36. Really?
Yes.
Are you sure? Because
No.
here, if you just divide this, right, 6, 6, how many possibilities do we have? We have 36, right? So
Yes.
among this 36, it says that Tom rolls a six-sided die, Jerry rolls a second six-sided die. Tom wins if the values shown differ by 1. So that means that maybe it is 6, 5 or 5, 6. It is maybe 5, 4 or 4, 5. It is maybe 4, 3 or 3, 4. It
And
is
then it's
3,
10
2,
over 6.
2, 3, right? And 2, 1, and 1, 2. All of this, actually, the difference is 1. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is
Teacher,
10
but
over 36. Right? The probability that the Tom wins, right? Let's say, what is it? Tom wins is equal to 10 over 36 by 2. It is 5 over 18.
teacher, but when it's a differs, it doesn't has to be more. It means one more.
Say again?
Teacher, it said Tom win if the value shows it differ by one. Usually when there is something like when you roll dice, you have to have more.
What do you mean?
Like it shouldn't be more. It means Tom has to have more.
The different one means that the difference, right, between the numbers is 1. It doesn't matter which one is smaller, which one is better. When you just find the difference is equal to 1. So as you see here, if you look at this number 6, 5, 5, 6, the difference between these two numbers is 1, right? 5, 4, 4, 5, 4, 3, 3, 4. All of these numbers, they differ by 1. And how many possibilities do we have here? 10. So 10 out of 36 choices, that is 5 over 18. Okay. All right, guys,
Oh,
let's solve next question. Eldar, I hope you will solve the next question correctly. A little bit tricky question. Can you read it and solve it? You have 2 minutes. It's an easy question. 2 minutes.
For how many integers and one smaller than n and smaller than 200 such that 5 n um 1 is a perfect square.
5n to the power of 5n is a perfect square. So that is 1 is less than or equal to n is less than or equal to 200, right? Such that, do you know what is perfect square, Eldar? Eldar Chalabov.
What can you repeat?
What is a perfect square? Can you give me some examples for perfect square?
Um 5 to the power of 2, for example.
What is a perfect square? The square of any natural number is a perfect square, right? Like 1, 4, 9, 16, 25, 36, 49, 64, 100, because all of these numbers are square of a natural number. 1 square, 2 square, 3 square, 4 square. All of these numbers are perfect square. And the question says that how many integers n, which is between 1 and 200 inclusive, such that 5n to the power of 5n is a perfect square.
200 because all of
200?
them are natural.
200?
198.
Because all of them are natural.
198? How is it possible?
All of them are natural.
No, it must be the square of a
Yeah.
natural number.
Natural was what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay, for example, Arad, you are saying that every number, like let's say if n is equal to 3, for example, 5 times 3, 15, and 5 times 3, 15, 15 to the power of 15, it's not a square number. For example, if n equals 1, for example, 5 to the power of 5, it's not a square number, perfect square number.
But what is perfect square?
I just explained. I'm saying that what we mean by perfect square. Okay, any
You mean
number, if you just pick any n, okay, that is natural number. So this n squared is called perfect square.
teacher? But that's impossible.
Oh, all right. Before thinking you're answering this, how about you, Narmin? Did you understand the question?
Yes, I understood the
And do you have
question,
any
but
answer, Narmin? What do you think? How many such numbers are there? Or how many integers n we have so that it makes this 5n to the power of 5n a perfect square? Narmin, any idea?
no,
No, why not?
I don't know.
Why you don't know? Do you know why you don't know?
No.
Yeah, so you don't know why you don't know.
Yes.
Why you don't know why you don't know, huh?
I
Okay.
don't know.
Okay, Narmin, okay, good. Just listen to me then. So once again, perfect square is the square of a natural number. We call this perfect square. In algebra, if any expression can be written as a plus b squared, then we call this also perfect square for algebraic expressions. But for natural numbers, square of the numbers, right? What are those numbers? It is 1, because 1 is 1 squared, 4, 2 squared, 9, 3 squared, 16, 4 squared, 25, 5 squared, dot, dot. These are perfect squares, or just simply we call them square numbers. So now, so here, if you look at this question, 5n to the power of 5n, right? To be perfect square, that means that when this number becomes a square of a natural number, so this 5n must be even number, right? If 5n is even number, suppose that this 5n is equal to 2k, right? Then I can write this 5n as 5n to the power of 2k. That's equal to 5n to the power of k, whatever it is, right? Now here I have the square of this number. So that is a perfect number now. So that means that now first I need to count what numbers make this 5n even number. All of the even numbers make it perfect. I mean, even, right? So what are those numbers? Then possible answers are, it is 2, right? 4, 6, dot, 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 inclusive 200, right? And that's the first point, but we are not done yet. We have also some special case here. Sometimes, right? And also this 5n itself, it may be, what is it, a square number, right? For example, let's say 5, let's say n is equal to 5. What do we have here? Here we have 5 times 5 to the power of 5 times 5, 25. What is 5 times 5? It is 5 squared. So it is 5 squared to the power of 25. Or using the property of exponent, I can write it as 5 to the power of 25. And here we have squared. So something 5 to the power of 25, it's the natural number and it is squared. So that's also perfect number. It is perfect square. And how about if n equals, what makes again the square? 5 squared, again, 5 to the power 1, 5 to the power of 3, right? Another one is, how about here we have 5 times 125. So here we have, what is n? 125, 5 times 125. Again, this 5 times 125, we can write it as 5 to the power of 4, or simply 25 squared. And here we have 5 times 125, that is 625. So I can write it as 25 to the power of 625 and to the power of 2. So also here, we have two more numbers here. So I need to add this to our list. So here 200 and plus, and also 5 and also 125. When n equals 5 and 125, that number, that 5n to the power of 5n, also it becomes a perfect square. So what is our answer then? Our answer is 202 numbers.
It shouldn't be 102.
102, sorry. 102. Okay, Narmin, is it easy? It's not so hard question, right? Just the tricky part is here. Can you also see that or not? That's why they ask here.
Yeah.
Okay, guys, let's move to the next question. Then, all right. How about this question? How many positive integers not exceeding 2013? Not exceeding means they are less than or equal to 2013. Are multiples of 3 and 4, but not 5. Right? They are multiples of 3 and 4, but not 5. So that means that here, what numbers are multiples of 3 and 4? We know the 3 and 4, we call them actually, how do I call that? Relatively prime numbers. We call this 3 and 4 relatively prime numbers because the only common factor of these numbers is 1. So that also that means that all numbers which are divisible by 3 and 4 are the numbers which are divisible by 12, right? So we are talking about these numbers here. We have 12, 24, 36, 48, and 60. There's a special one. And after that, continue, right? So number one, if I just find this, how many numbers are divisible by 12 between 1 and 2013? And after that, we need to subtract how many 60s do we have here, right? So now how many numbers are divisible by 12? The last number that is less than or equal to 2013 divisible by 12 is, what is it? It is 2012, I think. It is divisible by 3, 3, 5. No, it is not divisible by 3. Divisible by 4. And how about 11? 10. Okay, that's not divisible by 3. So the greatest integer, which is less than or equal to 2013 and divisible by 12, is 2010. Is that correct?
I
Because
didn't calculate it. It's 2004.
no. 10 is it not divisible by 4. So
2004.
2000,
2004.
2004. Yeah, that's right. Because 2010 or the other numbers to be divisible by 3, that some of the digits must be divisible by 3, and the last digit must be divisible, 2 digits divisible by 4, then they are divisible by 3 and 4. Okay, that's 2004. What is 2004? 2004 is divided by 12, that's equal to 167. This one is 167 times, what is it? 12. Okay, so here from here, this one is 1 times 12, 167 times 12. So here we have 167 numbers which is divisible by 12, and it says that not 5, right? So minus how many numbers are divisible by 60? So the first number is, let's say, 60. It is 120 dot dot, and what number is divisible by 60? Is it if it is 30, 1033. Is it 33? I think it is 33. 33 times 60, which is equal to 189. 1890.
1980.
Huh?
1980.
980. Sorry, confused by one. Because it is 3 times 6, 18, 18, 19, 1980. How many? 1 times 60, blah, blah, 33 times 60. So minus 33, that's equal to 134. So here we have 134 numbers between 1 and 2013. which are divisible by 3 and 4, but not 5. Okay. That's our last question. Let's discuss this and finish the question. Guys, can you have a look and think maybe at least 1 minute? After that, let's discuss this. Any idea, Javid, Narmin, Eldar, Arat? How do you solve this question? Or how would you answer this question?
Maybe 42.
I mean, how did you get 42?
I'm guessing maybe. No, because first I searched like if it be regular, every angle should be 154 point something. Then I saw that was not relating. And if it do, it means one side should be like this slope. I don't know.
Okay. I don't know how to solve, how to explain this question. What we have to know here is you are talking about 14 gone, right? It is regular. If we just find one angle, right, one interior angle, that's equal to 14 minus 2 times 180, and we should divide this by 14. That is equal to 12 times 180 over
1080 over 7.
huh?
1080 over 7.
1000?
1080 over 7, which is equal to 154. Point, 150, 154 and a fraction of 2 over 7.
Okay. All right. So what I'm going to show here is if I take 2 points, for example, here we have 14 side, right? Above these 2 points, we have 6 points, right? So here we have 1, 2, 3, and in such a way that here we have 1, 2, 3, and 1, 2, 3. In similar way below this line, okay? But we can show that actually, if you just draw, this one is 1 point, and this one is 1, 2, 3, 4, 5, 6. Let's say a 1, 2, 3, 4, 5, 6, 7, 8. This one is a 8. Okay, continue. Okay, so here I can show that actually that if you just join this diagonal, this is a diagonal, right? And that that is the diameter of a circle, that this polygon is inscribed in the circle. That means that all of these points are on the circle. Okay, and not just draw it, it will be so messy. Maybe you can draw something like this. Okay, draw something like this. And after that, join this. Here we have the first one, the second one, and third one, fourth one, fifth, five, six. Now it says that how many right angle triangles can be formed by joining 3 vertices of a given regular hexagon. But how can we prove that actually if I draw this, we know that it passed through uh, the center, right? Because here below this we have 6, right? Above this we have 6 points. So this A point and this A8, it is in the middle. So if you just join them, this diagonal must pass through the center of the circle, number one. Number two, for example, as you see here, if I just join these points, right? If I just join these points, and you know that this angle is subtended by the diameter, right? That means that this angle is 90 degrees. Any angle subtended by the diameter on a circle, it is 90 degrees. Now using this one, how many I can form here? From
One.
this one, right here we have how many points? A one, two, three, four, five, six, seven, eight, right? And just joining three of them. How many?
In total, we get 12. 6 up, 6 down.
No, not six. Okay, but how many triangles using only these points above this diameter we can form? One,
6.
A1, this one, right? A1, this two, A1 with, for example, here, using A1, right? Using A1, how many triangles? One, two, three, four, five, six, right? I can form six triangles. It's gone. Now, how about using A2? We can form five. Using A3, we can form four. Using A, not four, for example, this one, let's say A2, A3, A4, A5, A6, right? So, three. Using A5, right? A1, A5, A8, and A1. So it is two. Using A5, only one, right? So how many? Six plus
Teacher, but
five plus, it is six plus five, it is six times seven over two, 21. Is it?
there is one thing as well. When you create A2, the diameter will be A2, A9. So again, it will create 6.
Six?
Yes, all of them will create 6 because
No, no, I'm
A1
saying
is
that look, here actually it's just permutation, right? Here, starting from A1, suppose that one vertex of the triangle is A1. So using this one, how many triangles I can form? I can do A2, one triangle. A1, A3, A8, one triangle. A1, A4, A8, another triangle. A1, A5, A8, another triangle, right? If I just write that nicely, now you can see this. Here I have A2, A3, A4, A5. Is something missing here? A2, 1, 2, 3. This should be A4 here. Okay, this one A5, this one is A6, and here we have A7. A1, A2, A8, 1, A1, A3, A8, 2, A1 will continue until A1, A7, A8. How many? 2, 1, 2, 3, 4, 5, 6, right? So here I can form using one vertex, A1, I can form 6. Okay, now I'm moving this. How about
but
one vertex is A2, right? Not including A1. How many? It's just 1 point less. I can make 5. And this is A2, A3, A8. A3, A2, A4, A8. A2, A5, A8, right? So we can make 5.
teacher,
One,
but
two,
there is
three,
another
four,
thing.
five, 6. Huh?
You should have the whole circle, not only the half.
No, no,
Because when
I'm
you have
no. Arad, actually this circle, it is symmetric, right? After that, I can just multiply this 2. Also below the
not,
diameter, the same thing happens.
but you can draw a line from A2 till A9. Then that one would be new diameter and new half circle, so you will have again 6.
Okay. Now let's do like this. Okay. Next time maybe I will draw this nicely, and after that I will explain this. And here actually the 6, 5, 4, 3, 2, and A5 using A5. Here we have okay A5, 6, A2, 5, A3, 4, A4, 3, A5, 2, A6, 1. So how many? It is 6 times 7, 40, 21. 21 above, 21 below. It should be 42, if I'm not mistaken. Anyway, Aras, we will discuss like this, okay? I will just save it and drop in WhatsApp. If you have time, have a look, okay? Next time I will continue. Now other group is waiting, okay? That much is enough for today. Let's meet on Friday. I will drop the questions and We will continue from here on Friday. Okay, thank you. See you on Friday. Bye bye.
Bye.
Bye. Thank you.